everyone. Welcome to our YouTube channel, Becoming a ROS Developer. I'm Desire, and today we've got Ahsan, who has completed the course Linux Basics for Robotics, and he'll be giving us a presentation on that. So, what I'm going to do is to hand over the platform to him so he can begin his presentation. All right. Let me just capture the screen really quickly, Ali. All right, you can go ahead and begin.
Hello.
Yes, you can hear me. Can you hear me?
So, hello everyone. Yeah, I can hear you.
Okay, good. Let's go.
Hello everyone. My name is Ahsan Ali, and I have completed the course Python Basics for Robotics on the application on the website of the construct.ai. They have provided the stuff in which we can learn the Python's basics, particularly related to the robotics. In that course, we have to do also the project, which is related to the movement functions of the robot. We have to perform it on the simulation and also on the hardware of the real robot. For that, I'll be going through the presentation of the robot, which is the real robot. So we'll just begin with that. First of all, I'm workspace uh, for the robot.
So have you connected to the robot yet, Ali?
Yeah.
All right. Yeah, you need to connect. So we start there. So
Session not started yet.
just refresh your page. You
Time
should
is
see.
11.
Yeah, or close and open that window one more time. You should see the button green.
Yeah, exactly. Okay.
Can you try? Okay, let's give it a couple of seconds. Maybe you can try disconnecting and connecting one more time. You can hear me, right, Ali? Alright, Ali, can you hear me? Okay, I think we have lost him. So, Ali, can you hear me? Hi, Ali, are you still there? Alright, we seem to be having a network issue here, so let's see if we can. Okay, can you be explaining what you will be doing, Ali?
Yeah, first of all, I have first workspace, and now I'm gonna launch the ROS to launch file for the real robot we have connected virtually to.
Mm-hmm.
So
Okay.
so inside the package first for real robot, we have the launch file for which is main underscore. Yeah, this one launch file. So
And why do you need that?
we need to connect it to the robot, and we also have the RVs
Okay, so basically
in
you're
which
trying
we
to let
can see
to,
the uh, through the visualization tool, and this is a visualization tool.
okay, okay, so
RVs.
you want to see the sensor readings being displayed. Okay, all right.
And ROS to run, and we are running this command to control
Mm-hmm.
this is the same one. So in this case, we can use these keys to control the robot with the help of this, like, yes, to stop the robot, we're using K. And the sensor readings are being displayed over here in the real time.
Mm-hmm. Okay. All right. So let's get to the main
And
part.
now
Yeah.
we're, yeah, now we are gonna run this. First of all, we'll be navigating into the workspace where we have this code of the Python. So the space is in the home tab. We have the ROS2 workspace where we have this is the workspace in which we are working for, in which we are working, and we have the src file, and within the src files we have this workspace in which we have coded our program for the robot.
Mm-hmm.
So there are two files actually. I can show you from here also.
Yeah, we can look at those
So
later.
we
So
have,
yeah, let's see what
yeah,
the effect or how they work.
okay.
All right. So what is going on at the moment? So can you explain to us?
So first of all, the robot will move forward, and then it will move backward, then it will move right and left, and according for the specific period of time according to the functions we have created.
Mm-hmm.
And navigate the distance it measures from the wall, and will calculate the linear and angular velocity. And when there is obstacle, like when there is wall, it will try to return it, and this program will run for over for almost, and the robot will navigate to that. It depends like whether there is an obstacle. If there is an obstacle and the distance is on the left is less than the threshold, which is 0.300 something, and we can move the robot on the right so that it can follow the distance from here. But as we can see that it's going crazy, we can control it through the joystick.
Yeah. So this is your non-classed version, right?
Wait, this is a robot control class. We have the movement functions, we have the automatic functions, we have the,
Yeah, I would suggest you
just
stop the
stop it.
execution of that so that you can explain what's going on there.
So it has stopped.
Right. So my question to you was the classed version the one you're running
Yeah,
right now, or it was the non-classed version?
it was a class. Yeah.
The classed version, right? So that's the one you're supposed to have obstacle avoidance implemented, right?
Yeah.
Mm-hmm. So can you explain to me what was
So
going
in
on when
this,
it? Okay, go ahead.
so in the movement functions, first of all, the robot will get the velocities which we have. In this case, we have the two velocities: the linear velocity and the angular velocity of the robot. The linear velocity is for the linear movement, and angular velocity is the movement of the robot around its axis. We use it for the turn. And then we have also the function which is the stop robot function. And in this case, the linear and angular velocities both would be zero. And then we have the move front function. In this case, we are passing the variables like self. It's a variable we have every time in Python when we are creating the class. And the linear is the function we and linear is just variable for the linear velocity for moving the robot in the forward direction, because in this case we need only the linear velocity, not angular velocity, for the robot to move forward.
Mm-hmm.
And
Yeah,
then
yeah.
same is the case
Okay.
for the backward, but with the negative sign.
All right, all right. So I think these functions are quite self-explanatory, right? What we want to see and understand a bit more is how are you making your robot capable of avoiding obstacles or stopping before it collides, right? So maybe let's move to that function and you can explain the logic in there.
So there are the laser scan functions pre-provided in the repository, like
Mm-hmm.
in the code,
Mm-hmm.
and these functions are provided, and we have to use this to get the minimum scan angle of the robot, like the minimum scan of the laser from the wall, and also the maximum scan range. In this case, the robot is using 660 rays, and we
Yeah.
have calculated the formula depending on that.
Yes.
So
So those are your getters, right?
we
I
have
want to
the
see where you're using
obstacle
them. Yes.
prediction.
Yeah.
Yeah. So in the obstacle prediction part, we have all ranges, and we have from them we are using this function get all scan ranges. From here, get all scan ranges, like all the rays of the robot will be scanned, and then it will predict the front index depending on the angle to the index, which we have set it to 0, and the index we have set for 45, and this one is angle to index. This is a function we have, this is pre-provided, and the start index will start with the minimum, and the end we will end it with the maximum. And then we have the front ranges, which are all the ranges, and it will just for that angle it will specify it to the specific for the front scan only, which is minus plus and minus something like from 45 for just 90 degrees from the front range, which is exactly in the middle of that. And the front filter, we have filtered it like v is the variable we are using for the front ranges, and if the float is not infinity, and this is also a method in ISNAN v, and if not front filtered, then the robot will predict like the obstacle prediction, like for if in the front there is no obstacle for the threshold, the robot will say that there is no obstacle.
Mm-hmm.
And
So
then the minimum front
can
we
you tell
have
me
the
something about the function that is at the top, right? So under what circumstances do you get those either not a number or infinity, right? Can you elaborate
sorry,
more on that? Why do you need to filter for not a number or is infinity?
float is not a number, and why is it infinity?
Why do you need to filter for those, right? Why do you need to have that?
Because the distances were made in 300, like there are more integers, and the range is more specific, like it's more sensitive. That's why we are using in software we are using 0.0 something like this.
Can you say that again? Can you repeat that explanation one more time? You said?
Like for the float, we have this threshold 0.300. So there are more decimal points. So we are using floats in this case.
Yeah, no, I didn't say why do you use the data type float. I said why do you need to filter for those extreme cases, right? What would happen if you just process your LiDAR scan data like that? What would happen without filtering for any of those?
Sorry, could you please repeat?
My question was, why do you need to filter for those two extremes, right? What would happen if you don't filter for infinity and not a number? What would happen in your LiDAR scan processing, particularly when you are looking at
Yeah,
its infinity values?
the infinity value is the value that the robot, for example, if in the front we have set the threshold like this. If the threshold is not this, then the robot will predict is an infinity. And when it reaches the threshold, it would just calculate it like and so will
So
not detect it, and that's why we have specific value which we have set it in this case.
So okay, let's go step by step here. Do you understand why you need the threshold? Like, what do you understand the role of the threshold in this algorithm?
Sorry.
Do you understand the role of setting a threshold? Like, do you understand what it does for your obstacle avoidance?
For obstacle avoidance, we are setting this threshold.
Yes. Do you know the purpose of the threshold? Why do we have that? Can you explain to me?
Yeah, the threshold is set because when the robot will reach the threshold value, it will predict the obstacle. And we have stored this variable for the robot to predict the obstacle in this case. Because if you don't get, because for the obstacle you need the specific sense to detect it from. And in this case it's 0.300.
So you're saying that if the robot does not get to that threshold, it won't detect an obstacle, or you're saying that it it is always
It, it will
detecting.
it will continue moving. It will continue moving if it does not detect that obstacle.
So basically, the purpose of the threshold is to make sure the robot does not collide, right? That's what you wanted to say.
Exactly.
All right. So
Like it
now,
does not collide, it just predicts the obstacle and it predicts it like at what distance it is. So if it's greater than 0.300, it will continue moving, and if it's less than 0.300, then it will detect it and predict accordingly in which direction it has to move.
now let's go back to the question that I was asking you. I was saying when you process your LiDAR scan data, right? So obviously you are processing them in comparison to your threshold, right? How does infinity
Yes,
values affect the decision of your robot, right? Because you said you have to
how does
process
the
it when
infant?
it gets to that threshold, i.e., when it gets that close enough to an obstacle. So, my question was,
Yep.
how does not filtering infinity values affect your algorithm, right? How does it affect that process of deciding whether you should go forward or not, whether you should turn left or not?
With infinity values.
How does that affect that process?
So the infinity values in this case, like the threshold is being set, and if the robot is not detecting the threshold value, and these are beyond from the threshold value, then it will detect as infinity, and it will continue moving forward.
Okay. All right. I think I see where you're trying to go. Maybe you're struggling to explain a bit. Yeah, but basically, what I'm looking for is that you don't want to
Yep.
predict that you have got the distance that you don't have, right? So ideally, you're discarding those values because they are misreadings, right? Your robot is operating in a room that has got four bounded walls, right? So under no circumstance
Okay.
would you have values that give you infinity, right? That's a misreading, or that's LiDAR maybe going through past some slot or something, but you don't want to have that as your sole greatest distance, right? So from what I could understand, you wanted to go in this direction, but maybe the explanation was falling short. However, I will say let's go on for now, and then we can be asking more questions as we go. So we are running out of time a bit, but I'll give you 5 more minutes to wrap it up here.
Yep. So in this case, the direction tracking which was a part three of the robot, like it will track the direction in which direction it's moving. Have the tree, roll, pitch, and yaw. And in this case, it will get the data from the get orientation, and we have provided the variable yaw in it, and it's in the form of a list. And the second is we have the directions. These are pre-provided, like we have the 16 directions. These are pre-provided in the explained document. And we have the knife obstacle avoider, and the knife obstacle avoider we have threshold to 0.350 meters,
Mm.
and then we have the linear velocity is 0.15, and angular speed is angular velocity which is 0.5,
All
and
right.
we have calculated.
All right, so let's do this, right? So basically, you're taking us through what how your system is designed and what its function does, right? But remember, the idea of this project that you did was mainly to compare and contrast how your class version and your non-class versions differ, right? So can you explain to me
Exactly.
how those things differ, or which one did you find to be usable and why, and what did you learn about the differences?
In the class variables, we do is like we create the class and we pass the variables in it, and these variables we can use it repetitively in the same program, and we does not require them to be like in to use them again and again. However, in the no class file, like here in this case,
Mm.
we are using directly the variables each and every time,
Mm-hmm.
and we are passing the variables over here, and then uh, we have to do it like this. Like, but in the class variables, we just need to pass a variable one time, and then we can directly consider, like here in this case, in no class, we have created this one. You
Mm.
can see, but
Mm.
in the class
Okay.
variables, we create the classes, and we create the functions within the classes,
Mm-hmm.
and we can use those variables for the multiple times whenever we want to use them in the program. So
Mm-hmm.
it's easy for us to use the class variables. It's a big hectic, like it could go, you have to develop the logic accordingly. But in the no class variables, you have to use the variables each and every time. Like here, you see we have
Okay.
created
So
angular, we have to provide them again and again.
right, right. So there's one word for this, right? So I'm going to ask you to name this one word that the process that you've been describing here. There's one word that it's given. Can you find it in your head or somewhere? What is it called?
Sorry,
The idea of putting data
object-oriented
together.
programming.
Yes. There's something more. There's a more specific word.
Object-oriented programming. These are the we create the objects.
Yeah, no, okay, fine. The word I'm looking for is encapsulation, right? You can bundle data with the methods on which that works on those data, right?
Yeah,
That's
the
basically
methods or
what you.
functions.
Yes, that's basically what you're explaining. Yeah, so I was looking for the exact term. Yeah, it's still object-oriented programming, but the more exact term I wanted to know was this one. Anyways, thank you very much. We are a bit out of time, but thank you
Yep.
for getting the courage to come and showcase your project. We saw that your robot could avoid some obstacles. It collided in some instances, right? Um,
Yep.
but a job well done, and also thank you for getting the courage to come and make an explanation, present your work. So let's wrap it up here, and we can finish our conversation on Zoom. All right. Alright, everyone, this was Ali Hassan's presentation, and I'd like to encourage all those of you who would want to try a similar course, Python Basics for Robotics, or any other ones, for example, Linux Basics for Robotics, or